On behalf of Vincular, I would like to extend a warm welcome to all of you to today's webinar on the COMSEC Scheme. My name is Kalpana Mir and I will be your moderator for today's session. We have an insightful discussion planned to bring together experts from our Vincular, NCCS and testing laboratory. So without further ado, let's get started. For those joining a Vincular webinar for the first time, let me briefly introduce our organization. Vincular is one of India's leading regulatory compliance consulting company. Since 2012, we have been helping businesses meet regulatory requirements and achieve compliance with confidence. Our services include regulatory consulting, product approvals, certification support, risk assessment, policy guidance, and compliance management across sectors such as electronics, IT equipment, wireless and telecommunication, medical devices, renewable energy, waste management, and more. The next slide provides a brief overview of the services and solutions offered under the Vincular's umbrella. Before we begin, we would also like to let you know that the presentation deck and webinar recording will be shared with all participants after the session. Now, let's turn our attention to today's session and take a look at the agenda. We will begin with an introduction to DOT, NCCS, and MTCT, followed by an overview of the COMSEC scheme, including its scope, objectives, test requirements, and the product covered. Next, we will discuss the COMSEC certification process, including the different certificate types, certification workflow, and expected timelines. During this session, our experts will talk about the COMSEC framework, its importance in strengthening communication security, and the impact of the graded certification scheme. They will also discuss the industry's readiness and the key consideration for compliance. We will also cover some recent updates and key industry developments before opening the floor for the questions and discussion. Throughout the webinar, you can also submit your questions using the Q&A panel. Our team will try to answer some questions during the session, while the remaining questions will be taken up during the Q&A discussions towards the end. To start the session, I would like to introduce Mr. Sameer Azam Khan, Team Lead in the Regulatory Compliance Team at Vincular. He holds an engineering degree and has extensive experience in MTCT and telecom certification requirement. Mr. Khan has been closely involved in helping global manufacturers meet India's telecom regulatory requirements, including MTCT and COMSEC compliance. Today, he will provide an overview of the COMSEC framework, its key requirements, and what organizations should know as they prepare for compliance. We are pleased to have him with us today. Over to you, Mr. Sameer.
Thank you for the introduction, Ms. Kalpana. So before we discuss the COMSEC scheme, let us first understand the regulatory framework that supports India's telecom ecosystem. We have observed that every day we make calls, send messages, attend online meetings, stream videos, navigate using GPS, and make digital payments. Behind all these activities, there is a vast telecom infrastructure. Imagine if the equipment powering these networks was faulty or contained security vulnerabilities. Then the consequences could range to serious security threats affecting critical national communications. To prevent such risks, the Government of India, through the Department of Telecommunications, known as DOT, establishes policies, regulations, and standards for telecom equipment. DOT comes under the Ministry of Communications and is responsible for creating regulatory policies for telecom equipment, spectrum management, operator licensing, and digital connectivity initiatives, and ensuring overall compliance with the telecom standards. Although creating standards is the only first step, but the main challenge occurs ensuring that equipment entering the Indian market actually complies with them. And this is where the idea comes into the picture of mandatory testing and certification of telecommunication equipment scheme, known as MTCTE, introduced by Telecommunication Engineering Center, known as TEC. MTCTE scheme was introduced with the plan that all the telecom products entering Indian market must be tested with the EMI/EMC, safety, technical, RF, and security requirements. So when MTCTE was introduced, security was one of the several compliance requirements covered under the certification framework. However, as the telecom networks became critical national infrastructure and cybersecurity threats increased, the Government of India established NCCS as the specialized authority for the telecom security. This allowed security evaluations to be handled by dedicated cybersecurity experts through the COMSEC framework, while MTCT continued focusing on technical, safety, EMI/EMC, and performance compliance. As a result, MTCT ensures that telecom equipment works correctly while NCCS ensures that it is secure. In simple terms, we can say DOT established the rules, MTCT verifies that telecom equipment meets technical requirements, and NCCS ensures that the equipment is secure. Together, they form the foundation of a safe, reliable, and secure telecom ecosystem in India. So, as we have seen that telecom networks became more critical to banking, government services, healthcare, businesses, and everyday communications, the focus could no longer remain only on whether the equipment functioned correctly, and then the question became, is the equipment secure? So, this is where NCCS comes in. Its primary responsibilities include developing the ITSAR standards, establishing a security testing ecosystem, designated telecom security test laboratories, and ensuring compliance before market entry. This framework is intended to reduce telecom vulnerabilities, strengthen national cyber resilience, prevent unauthorized access, and secure critical communication infrastructure. This marks a major shift from only functional compliance toward comprehensive security compliance. As we understood the role of NCCS, let us come to the core topic of today's discussion, the Communication Security Scheme, known as COMSEC Scheme. COMSEC Scheme is a mandatory telecom security certification framework implemented by NCCS under the Department of Telecommunications. Under this scheme, telecom and communication devices must undergo security testing according to the ITSAR requirements before they can be sold, imported, deployed, or used in India. The testing is conducted at designated telecom security test labs known as TSTLs. The main objective of the schemes are securing India's telecom ecosystem, protecting telecom networks from cyber threats, ensuring trusted telecom infrastructure, and strengthening national communication security. Now, before we walk about the COMSEC certifies, it is important to understand why it exists. Talking about the numbers behind these policies are not abstractions. They represent real economic damage, real infrastructure failures, and very clear strategic threat. As in 2015, the global cost of cybercrime was estimated at $3 trillion. By 2023, that figure had reached $8 trillion. By 2025, projections put it at $10.5 trillion annually, which is larger than the GDP of Japan and Germany combined. This is not a technology problem. It is one of the largest economic forces on the planet. In India, nearly 14 lakh cybersecurity incidents in 2023 alone were reported. And here is the critical detail. 69% of all malware entering telecom networks globally enters through compromised routers, access points, ONTs, and these devices we are talking about certifying today. In 2016, the Mirai botnet enslaved over 300,000 routers and took down the large part of the internet, $110 million lost in hours. In 2018, VPN filter infected 500,000 routers across 54 countries. In 2021, India experienced a suspected grid disruption in Mumbai. Also, in 2023 and 2024, BSNL and Airtel saw massive data breaches affecting hundreds of millions of users. The router sitting in a home or enterprise is not just a convenience device. It is the front door of nation's digital infrastructure. And right now, many of those doors have no lock. So if I talk about what is India doing about it, the government has recognized something that many nations are still debating. In a digital economy, telecom security is national security. They are not two different things, they are the same thing. So consider the economic dependency. India's digital economy is projected to reach $1 trillion by 2026. The Unified Payments Interface processed 100 billion transactions in 2023. Every single one of those transactions traveled across the telecom infrastructure. A compromised router is not a device failure. In fact, it is a financial system failure waiting to happen. India's 5G rollout introduced 5 times the attack surface of 4G network. Meanwhile, foreign origin devices have been documented to carry backdoors. The supply chain for telecom equipment is a national security question, not just a procurement question. This is precisely why DOT, NCCS, and TEC have built the COMSEC certification framework and why 62 IT SARs have been already published, covering everything from smart meters to firewalls. India is certifying devices before they touch the network, prevention not reaction, and for OEMs in this room, compliance is not a barrier. It is an entry ticket into the most important market of the next decade. India has designed COMSEC to be progressive. Mandatory baseline requirements are live today, and the framework is actively expanding. Getting certified now puts you ahead of requirements that are only going to tighten. So, considering every clause tested, every certificate issued, and every router verified is a brick in India's digital shield. The work done in your labs and compliance team is not paperwork. It is national infrastructure protection and it matters. Let us now look at the products that are already covered under the mandatory COMSEC scheme. The journey began with the locally managed access points and routers became mandatory from 1st of July 2024. As telecom networks continue to evolve, the scope expanded to include the 5G session management function, known as SMF, that was brought under the mandatory framework from 1st January 2025. Most recently, PON ONT, PON OLT, and PON ONU products became mandatory from 1st of January 2026. This means that products getting covered under these categories must complete security testing and certification before market entry. For manufacturers and importers, this introduced new responsibilities related to security documentation, product hardening, and secure configuration compliance. As a suggestion, organizations planning future product launches in India should begin preparation early because security testing can take significant time. Now, having looked at the products that are already mandatory, let us now look ahead at what is coming next. The expected mandatory products include cloud-managed access points and routers. NCCS has already finalized ITSAR standards for cloud-managed Wi-Fi CPs. The expected mandatory implementation date is 1st September 2026. Additionally, NCCS has finalized around 62 ITSAR standards covering various telecom and communication products, including LAN switches, smart meters, firewalls, and other network security devices. As not all are mandatory today, but this clearly indicates the future direction of India's telecom security ecosystem. Thus, we suggest organizations should therefore proactively evaluate their products against the ITSAR standards even before enforcement begins. With that background, let us now move to the next topic and understand how products are categorized under the COMSEC framework as locally managed and cloud-managed devices. So let us start with the locally managed devices. These devices configured and managed directly by the user or network administrator within the local network. To make changes, monitor performance, or update settings, the administrator typically logs it into the device using its local IP address or through an on-premises management system. The advantage of locally managed devices is that the organization has complete control over the device and its data. Now let us look at the other side of the picture, the cloud-managed devices that are connected to a cloud-based management platform. So instead of logging into each device individually, administrators can monitor, configure, and manage devices remotely through a web portal or a cloud dashboard from anywhere within an internet connection. Cloud-managed devices offers benefits such as centralized management, easier software updates, remote troubleshooting, and better visibility across the network. However, they completely rely on internet connectivity and require secure communication with the cloud platform. With that understanding of locally managed and cloud-managed devices, I will now hand over the platform to our moderator who will introduce our guest speaker.
Thank you, Mr. Sameer, for that insightful overview of the departments and COMSEC scheme. We will get back to you in some time. Moving forward, it is my pleasure to introduce Mr. Ashish Chugh, Director, Security Assurance Standards, NCCS DOT. Mr. Chugh has been closely involved in the development of ITSAR documents at NCCS and has played an important role in shaping India's telecom security assurance framework. In today's session, Ashish sir will share insight on the strategic importance of telecom security, the evolving cyber threat landscape, and the significance of the critical telecom infrastructure rules. He will also provide an overview of the MTCT, NCCS, and COMSEC scheme activities and notified ITSARs and TSTLs, the current certification status, and the way forward for building trusted and secure telecom network in India. We are honored to have him with us today and look forward to hearing his valuable perspectives on this very important subject. With that, I would like to warmly invite Ashish sir to take the session forward. Over to you, sir.
Thank you so much. Thank you for this opportunity. So I'll be explaining about COMSEC Scheme, the Communication Security Certification Scheme for Trusted Networks and Safe Nation. My name is Ashish Chugh, and I'm looking after the Security Assurance Standards Division of NCCS as Director. So first things first, telecom network is a critical telecom critical infrastructure of India. You can name any sector, for example, banking and finance, military and defense communication, emergency communication, disaster response, power grid, intelligent transportation system. You take any infrastructure, anything, it critically depends upon the telecom sector. Telecom also forms the backbone of digital India and smart governance. For example, Aadhaar-enabled citizen-centric schemes, distance learning, telemedicine. It's no surprise that these telecom networks are facing a risk of espionage, sabotage, and data theft at the hands of many nation and non-state actors, state and non-state actors. So telecom security plays a strategic role, and it has a strategic implication in geopolitics and defense. Who is able to control the telecom security can have a lot of leverage. Now talking about the threat landscape. In telecom sector, we already had a lot of legacy vulnerabilities, for example, SS7 signaling, diameter signal. Now in addition to these legacy vulnerabilities, we also have advanced persistent threats. These APTs may include installation of a malware, which are sophisticated. They can cover their tracks and remain undetected in the network for a long time and exfiltrate data without information. Then we also have ransomwares nowadays. Your information is encrypted until unless you pay ransom to the attacker, they will not decrypt it. And in many cases, they don't decrypt it at all. We also have a problem of compromisation of the third-party vendor. This is the supply chain attacks, where an attacker will not directly attack the targeted organization, but they will install a backdoor with a third-party vendor. So when the data flows from a targeted organization to a third party, it will be exfiltrated by the attacker from it. We also have the problem of insider threats. This may be intentional or accidental. We're talking about the 5G. With the advent of 5G, several new features came in. For example, network slicing, where every slice of a 5G network can be given a different service, a different quality of service as well. But whether these slices are isolated, that is the problem. So there is a problem of data leakage between different slices. Now the core has been exposed via open interfaces. When we talk about traditional radio access network, it was closed. There was open interfaces. There were proprietary systems. But with Open RAN, there is this aggregation and there are open APIs. There is a lot of possibility of attacks, and the attack surface has increased significantly. With multi-access edge computing, also attack vectors increase, and with cloudification of the entire network, there are native cloud-related challenges. For example, we need to take care of the data protection in the cloud. We need to ensure that security logs and auditing happens, access control. All these things have to be taken care of when the cloudification has taken place of the entire 5G network. Now, to address all these issues, all these problems, Department of Telecom has come up with several initiatives, several measures. For example, one is Telecom Cyber Security Rule. As per these rules, there is a clear-cut definition of telecom cyber security. Telecom entity. Telecom entity is the telecom service provider or any other internet service provider. It has also defined what a security incident is. Under these rules, every telecom entity, that is a telecom service provider, needs to adopt a telecom cyber security policy. They need to establish a security operations center. They need to appoint a chief telecom security officer. And in case of a telecom attack or incident case, they need to report within 6 hours, and then the final report has to be further provided in 24 hours. In addition to that, there are also critical telecom infrastructure rules that have been notified by Department of Telecom, where Several networks of telecom entities have been designated as CTI based on their impact on national security, economy, public health, or safety. Such telecom entities have to provide access to these networks to the government for the inspection purpose. Further, the Chief Telecom Security Officer has to oversee the implementation part. There is severe or strict compliance or as well. They need to have SLAs as well. In case there is some repair or upgradation happening from the place outside India, these have to be notified to the government and permission has to be taken. Further, all these critical telecom infrastructure have to comply with government standards, for example, ERs, essential requirements of TEC, IRs, that is interface requirements of TEC, and ITSARs, that is Indian Telecom Security Assurance requirements of NCCS. Now coming to the mandatory testing part, that is MTCT. The Indian Telegraph Rules of 1951 were amended in 2017 and mandatory testing clause was added in those rules. As per this rule, every telecom equipment has to undergo mandatory testing and certification with respect of certain parameters, and it is determined by the Telegraph Authority. If there is no testing or certification, it cannot be inducted. So subsequently, mandatory testing and certification of telecom equipment scheme, MTCT scheme, was launched by TEC. There are 5 parameters in this scheme which is verified before giving a certificate to a telecom product. First is the EMI EMC, that is electromagnetic interference and electromagnetic compatibility should be within check. Second is safety with respect to human beings, voltage, current requirements should be within check. Third is the technical requirements, for example, the quality of service. Fourth is other requirement, maybe compliance related to environmental norms. For this is an example. And the last requirement is the security requirements. So the first 4 requirements, EMI, EMC, safety, technical requirements, and other requirements are taken care by TEC in their certification. And the last requirement, that is the security requirement of MTCT, is taken specifically care by NCCS, National Center for Communication Security. And we have a dedicated COMSEC scheme for implementing this security requirement. So NCCS, National Center for Communication Security, is responsible for implementing the COMSEC scheme. The major objectives of this scheme are that it seeks to develop a testing and certification ecosystem in India. Further, it tries to ensure that telecom equipment meets security assurance requirements. Without meeting those requirements, the telecom product cannot be inducted into the network. And it also envisages development of country-specific standards, processes, and specifications. So coming to breakup of the activity, there are 3 major activities that NCCS does under the COMSEC scheme. First one is development of India-specific security assurance requirements. These are Indian Telecom Security Assurance requirements. These assurance requirements are documented for every telecom equipment separately. Second is the designation of third-party telecom security testing labs. They are responsible for carrying out the testing of the telecom equipment as per the standards, that is the ITSA requirements. And once the product is tested, the telecom labs will provide those reports to the NCCS, Security Certification Division of NCCS, which will evaluate and certify the telecom equipment against those ITSAs. So there are 3 major activities. First is the development of standards. Second is designation of labs that will test those standards. And third is based on those test reports, evaluation and certification of the telecom equipment will happen and the certification will be issued. So we have 3 technical divisions in NCCS. One is the SAS, Security Assurance Standards Division. This division is responsible for framing the standards, that is ITSARs, and also the telecom testing schedule and test plans, PSTPs. And second division is the SLR, Security Lab Recognition. They are responsible for designating the private labs which will test the products. Third division is Security Certification Division that will issue the certificate based on the testing reports received from the lab. And fourth one is the HQ division, that is the administrative division that takes care of the overall administration in NCCS. So just I'll give a brief about how ITSAR is developed. So first of all, there has to be some trigger point which leads to development of an ITSAR. For example, if a technology comes in that gives a trigger for developing the new ITSAR. ITSAR is the standard, as we have already spoken about. It's a security standard. In case there is some lacuna in our existing ITSAR, we will try to revise it. Or there is some new sort of attack or something, some intrusion happens based on which some intelligence comes in. Based on that, some XR may be developed. So after getting the trigger, we will identify that a particular product, for a particular product, XR has to be developed. Then we will start collecting the technical inputs. For getting the technical inputs, we will refer to a lot of international documents, for example, 3GPP, PTSI, NIST CSF framework, cybersecurity framework 2.0. And in the second step itself, we will also have a pre-consultation with the stakeholders so as to ensure that whatever path we are taking for development of the HSR, it is in the correct direction. Based on that, we will draft the HSR. That will be the first draft. This draft will be internally reviewed by NCCS. Then again, there will be a major stakeholder consultation. This draft is given 60 days of time for consultation. It is published online, and 60 days are given for consultation from different comments from different stakeholders. Then there is a stakeholder consultation meeting where everyone is invited and they give their comments. After consultation, there is it's a technical committee where there are members from DRDO, Ministry of Home Affairs, and other departments as well. They will also give their inputs. After the inputs are collated and the final ITSR is prepared, it is presented to the head of the department of NCCS, who gives the final approval, and then only the ITSR is published. So right till now, more than 60 ITSRs have been notified or published by NCCS in different categories. For example, 5G network functions, 4G network equipments, core equipment, access equipment, customer premise equipment, transport equipment, and there are standards which are applicable to a group of equipment. And then there is a miscellaneous. There is one ITSR for operating system of telecom networks, telecom systems, devices. That is there in the miscellaneous part. So notification does not mean that this ITSR become mandatory from day one. So there is a notification date. This is a publication date actually, and then compulsion. If there is compulsory, it becomes compulsory later on. Then it will be the date of effect. That will be different. So till now, we have made 5 products for which testing or certification is mandatory. For example, session management function of 5G, IP router, Wi-Fi CPE, optical line terminal, optical network terminal. So we have published more than 60 ITSRs, but only 5 ITSRs are mandatory for 5 telecom equipments. So next is the process under which we designate the telecom security testing labs. So there is a structured process that we follow. There is a website on which the labs can apply. NCCS website is there. They can apply on that. So they need to provide the proof of legal status in India, accreditation by any recognized body, for example, NABL or something else equivalent which can give a recognition. Organizational structure, laboratory layout, and basically we need to understand that they will be able to, they are capable of testing it properly, and also they need to provide the quality manual, and they should be able to provide that they have good financials as well. Based on their application, there is a designation authority in NCCS who will agree to their documents, or there will be some requirement. Then there is a feedback loop under which it takes nearly 12 weeks of the entire process to complete. Also includes that visit from the officers of NCCS to the lab. Once we are satisfied, then only we will designate the labs. Till now, we have designated nearly 9 testing labs: QCert, Jewel India, Granite River Lab, Deltafi Labs, Metric Shell Technologies, Nemco India, IIT Madras Pravartak, and Tele Cyber Services, Compliance International. These are located in various parts of India, and they have been designated for IP router, Wi-Fi CP, firewall, 5G SMF, and also other devices. Last step is how the certification process flows, how you can apply for a certificate, and then how the flow is. So there is an MTCTE portal. Applicant can apply on the MTCTE portal. They can make payment of the application fee, which is a minor fees. They can choose the lab in the portal, which TSTL they want to go for. Once the TSTL accepts their request, SC division of NCCS, that is Security Certification Division of the National Center for Communication Security, we will get this notification. We will appoint one validator. And after validation, we will be in touch with the lab. Lab will submit the reports to the validator. Validator will oversee the entire process. They will verify the reports, evaluate them, and if everything is fine, certification will be issued to the OEM. Till now, we have got more than 150 applications for certification at hand from more than 22 OEMs. And as we have already spoken about, the mandatory equipments are 5G SMF, IP router, Wi-Fi CP, optical line terminal, optical network terminal. We have got a certification request for all these products. These 150 applications are in different state of evaluation and they are under progress. So just to summarize it, we are trying to, at NCCS, we are trying to align our standards with the global standards, for example, NIST, 3GPP standards, and we are trying to address the supply chain security as well. In this entire process, we are also trying to strengthen the indigenous testing capabilities of the telecom equipment in India. And going ahead, we are also investing in capacity building. For example, we are doing some R&D in post-quantum cryptography and AI misuse as well. So we will be incorporating some AI threat-related factors in our ITSARs as well. So thank you so much. That is all from my side. So basically, we have 3 divisions in NCCS. These 3 divisions are exactly same what COMSEC scheme is for. One part is about making the standards, developing the standards. We take help from IIT Madras, IIT Bombay, and other IITs as well while developing the standards. Then we designate the labs which will test the product against those standards. The third part is security certification. We start getting the reports from the testing labs. There is a validator who will be appointed from our office. So a validator will oversee the reports. They will verify, validate. Then based on the satisfaction level, certificate will be issued to the OEM. These are the 3 steps, and these are the 3 steps for the COMSEC scheme as well. Thank you so much. That is all from my side.
Thank you very much, sir, for sharing your valuable insights with all of us today. We truly appreciate your time and expertise, and your perspective have been extremely informative and beneficial for everyone attending this session. Now, to continue with the session and take us through the certification process, testing requirements, timelines, and the draft graded certification schemes, I would like to invite Mr. Samir Azam Khan back to the presentation.
Yeah, thank you, Kalpana. So in continuation of our today's agenda, now we will discuss about the different types of certificates which you might have seen in the NCCS portal that are issued under the COMSEC framework. The first is a PROTEM certificate. A PROTEM certificate is a temporary security certificate issued by NCCS, and based on this certificate, TEC issues an integrated certificate. So that acts as a bridge until the final COMSEC certificate is issued. This certificate allows telecom equipment to be deployed, sold, or used before full security certification is completed. It is mainly applicable to locally managed products like access point, routers, PON devices, etc. The validity period of the PROTEM certificate is generally 2 years. Once the OEM receives the integrated certificate, the product becomes eligible for import and deployment within India. This mechanism helps ensure business continuity while organizations complete full compliance activities. Moving forward, we will talk about cloud-managed access points and routers. The situation is slightly different. Since these products are currently exempted from mandatory security testing, NCCS issues a cloud acknowledgement letter instead. This exemption is currently valid until 31st of August 2026. However, based on the ongoing regulatory discussions, it is expected that the exemption period may be extended further. And in case if no extension is announced, then from 1st September 2026, cloud-managed access points and routers will also be required to undergo mandatory security testing and certification. Manufacturers should continue to monitor NCCS notifications for any updates regarding future compliance requirements for cloud-managed devices. Now coming to the third category, which is the provisional certificate. So this is also a temporary integrated certificate jointly issued by NCCS and TEC. However, it is specifically applicable to products that have declared end of sale or end of life timelines or the device that meet HSE criteria. Here HSE stands for a highly specialized equipment. If a product such as a router operates on a single phase or a 3-phase power supply with a current requirement greater than or equal to 32 amperes or operates on a 48 volt DC with a current requirement greater than or equal to 100 amperes, then the OEM is eligible to apply for a provisional certificate. The validity of the provisional certificate is generally 2 years. After receiving the provisional certificate, there is no need to conduct security testing on the product. As Mr. Ashish Chugh sir has already explained the COMSEC process flow at a high level, I will now further elaborate on each step and walk you through the complete certification process. The step 1 is the product assessment. In the first step, the product is evaluated to confirm whether it falls under the scope of COMSEC testing. Once the applicability has been determined, the certification process begins with the submission of an application through the MTCT portal. Moving forward to step 2, it is the profile creation and application initiation. In this step, the applicant first creates and registers an account on the TEC MTCT portal along with the required organizational and authorization details. It is important to note that a common portal is used for both MTCT and COMSEC certification applications. The bill of materials, generally called as BOM, are required for MTCT and NCCS evaluations, and the BOM is submitted through the same portal. After the BOM submission, a single application ID is generated to facilitate both MTCT and NCCS certification processes. The MTCT and NCCS both evaluates the submitted application and BOM files. After approval, we move to the next step, which is the government fee payment and lab selection. Depending on the product category A, B, or C specified in the applicable essential requirement documents, the prescribed government fee must be paid. After the government fee payment is completed, the applicant selects a TSTL through the portal. Once the selected TSTL accepts the testing request, the product samples are prepared and submitted to the laboratory for evaluation. This activity can be initiated in parallel with Step 1 or Step 2 to optimize the overall certification timeline. Moving ahead to Step 4, that is the hash verification process. So once the samples are received by the laboratory, the software or firmware hash values extracted from the device are verified against the hash values declared by the OEM in the submitted documentation. The hash validation activity is conducted in the presence of an NCCS official through a virtual meeting. After completing hash verification, TSTL submit the report to NCCS officials for validation. The step 5 is the protem certificate issuance. After the hash verification report is validated, NCCS issues protem certificate, which is the combined with the MTCT certificate and valid for 2 years. Step 6, the main security testing. The TSTL conducts security testing of the product in accordance with the applicable ITSAR. The ITSAR includes all relevant test clauses related to areas such as authentication, authorization, cryptography, fuzzing, and other security requirements that must be evaluated on the product. After the certificate gets issued, the lab starts testing and begins submitting completed test reports to NCCS for validation and evaluation in parallel. This means that while the remaining security testing activities are still ongoing, NCCS validators and evaluators can start reviewing the submitted reports and supporting evidence. Step 8 is the report validation and evaluation phase. In this phase, the NCCS validator starts reviewing the clause-wise test reports. After completing the review process, the validator forwards the reports to the NCCS evaluator for final evaluation and approval. During the report approval process, test clauses observations also shared by the NCCS officer and the OEM and lab together address the observations. And finally, step 9, final integrated TEC plus NCCS certificate issuance. So after completing the report evaluation process, NCCS issues the final COMSEC certificate for the product, which will be valid for 10 years. Now in this slide highlights the key security testing areas evaluated by during telecom security compliance assessments. Since the testing framework is divided into different categories, think of a security testing as a comprehensive health check for a telecom product. The evaluation begins with the access and authorization, where testers verify that only authorized users can access the device and perform critical operations. Next comes the authentication attribute management, which focuses on protecting user credentials and ensuring that passwords, keys, and authentication data cannot be easily compromised. The testing then moves to the software security, where the device software operating system and applications are examined for vulnerabilities that could be exploited by attackers. Another important area is the system secure execution environment, which verifies whether the device can securely boot, protect its firmware, and protect unauthorized code from running on the system. One of the most intensive phases is fuzzing. During this process, testers send unexpected and malformed data to every supported protocol to identify hidden weaknesses. Since each protocol must be tested individually, fuzzing alone can take nearly a month and typically requires an additional sample. So apart from the above, there are multiple test clauses depending upon the product ITSR. There are 92 test clauses in the router and 77 test clauses in Wi-Fi CPEs. Now that we have seen how certification framework is performed, let us understand who carries out the critical testing activity. NCCS has designated 9 telecom security testing laboratories known as TSTLs, which are set up across different states in India. These TSTLs play a very important role in the telecom security ecosystem. They perform security testing of telecom equipment based on NCCS and ITSR requirements, ensuring that each product meets the defined security standards before it is deployed in networks. Their key responsibility is to identify security vulnerabilities in telecom products and verify whether they comply with the national security guidelines. Based on the testing results, they generate detailed test reports, which are then submitted to support the security certification process. Throughout the entire testing process, TSTLs maintain strict confidentiality, impartiality, and integrity, ensuring that all evaluations are fair and secure. Now let us look at the overall COMSEC certification timeline. While the exact duration can vary depending on the product, testing outcomes, and NCCS processing timelines, this slide provides a standard project timeline under normal conditions. Let me walk you through each stage. The first activity is sample movement to the lab, which typically takes around 1 week. Once the sample is received, the lab performs internal hash verification. After that, official hash verification and submission of the hash verification report to NCCS takes approximately 1 to 2 weeks. Following successful hash verification, Protem issuance usually requires around 2 weeks, subject to NCCS processing timelines. The next stage is the security testing, which is the most critical and time-consuming part of the project. Depending on the product complexity and testing observations, this activity typically takes around 14 to 16 weeks. During the security testing phase, the laboratory does not wait for all testing activities to be fully completed before starting the review process. Instead, as and when test cases are completed, the lab begins submitting the test reports to NCCS in parallel for validation and evaluation. This parallel approach helps in improving the efficiency by reducing overall processing time and ensuring faster feedback on the test results. Finally, after the successful evaluation, the final COMSEC certificate is issued, which typically takes around 2 to 4 weeks. So in summary, the complete COMSEC certification process generally takes around 22 to 24 weeks, assuming the project progresses smoothly. In this slide, we will discuss some key updates and important points regarding security testing. Previously, NCCS required OEMs to submit the final software image intended for end users, and the entire security testing process had to be performed on this specific software version. If any test clauses failed during testing, the OEM was not allowed to modify or update the software to resolve the issue while the testing was in progress. However, NCCS has recently issued a new notification allowing OEMs to update their software during the security testing phase in order to address and fix the failed test clauses. Furthermore, NCCS has issued another notification stating that if a failed test clause can be made compliant through the implementation of hardening measures, the OEM must prepare a detailed hardening guide for that specific test case. This hardening guide must then be shared with both the testing lab and NCCS. The hardening guide shall not be in the form of advisories to the users. It should contain only the commands and steps required to harden the device by way of the configuration. Now, let me walk you through a recent proposal being discussed by the government to address some of the complexities associated with the COMSEC certification process. Please note that this proposal is still under discussion and the implementation timelines have not yet been finalized. When the COMSEC security certification framework was initially introduced, the security requirements were quite extensive. For many OEMs, achieving compliance with all the prescribed security requirements at one time would be a significant challenge, particularly for products with complex architectures or multiple features. Recognizing this practical difficulty, NCCS has been engaging with industry stakeholders to explore a more phased and manageable approach to compliance. As part of these discussions, a graded certification framework has been proposed, The objective of this proposed framework is to make the certification process more practical for manufacturers without diluting the overall goal of strengthening telecom security. Under this approach, instead of requiring products to comply with all the security clauses at the outset, certification may be granted based on the level of security compliance achieved by the product. This would allow OEMs to enter the compliance framework in a more structured manner and progressively enhance their security posture over time. As currently proposed, the framework would include three security assurance labels: SAL 1, SAL 2, and SAL 3. The exact number of test clauses applicable under each label, as well as the validity period of certification, are still under discussion between NCCS and industry stakeholders. Now, with that overview of the COMSEC process, the proposed changes, and the graded certification framework, I will now hand over the session to our moderator, Ms. Kalpana.
Thank you again, Mr. Sameer. I am sure the audience now has a much clearer understanding of the COMSEC framework and the steps involved in achieving the COMSEC certification. We will now hear from Mr. Sanjay Sharma, currently serving as General Manager, GRL, India Services and Cybersecurity Business Lead. Mr. Sanjay is a security professional with 23 years of experience specializing in telecom products, IoT device security testing, application security testing, governance and compliance, and third-party risk management. Mr. Sanjay has been instrumental in helping GRL achieve accreditations from prestigious bodies such as NABL, NCCS, BIS, and other authorized organizations, showcasing his leadership and strategic approach to compliance and security excellence. With certification including CISA, CISP, CEH, and ISO 27001 LA, he is adept at managing complex security programs and driving risk mitigation strategies for organizations to maintain strong security testing approach. We are delighted to have him with us today to share his insights on the draft graded certification schemes, its impact on OEM and testing laboratories, the test clauses covered under the scheme, and the laboratories' readiness to support COMSEC testing requirements. Over to you, Mr. Sharma.
Thank you, Kalpana and the Vincular team for inviting me to this webinar and providing the opportunity to share insights about the NCCS certification framework. I would also like to extend my sincere thanks to Shri Ashish ji, Director SAS Division NCCS, for giving his precious time to join this webinar and share his valuable insight about how the COMSEC scheme started, what are the different divisions working under NCCS, and what is the process of security certification and so on. So we are honored to have his presence with us today. So now we come back to the test clauses covered under the CC. So these are the test clauses for security testing, which in fact Samir has already discussed. These are the very important clauses which are part of the ITSA testing for all the related products. The access and authorizations, that means which is looking to the management protocols, management authentications, how management traffic being secure. So these are the important factors which have been tested on this access and authorization. Authentication attributes management, which covers on the enforced strong password. We should have a RBAC rule. We should have some protection against brute force and some dictionary attacks. So those tests have been performed. In software security, we perform some kind of tests related to secure update, related to source code security assurance, related to self-testing. It should be secure while booting. So there are many tests which has come into the software security that ensure that whenever what are the software installed on the devices are secure. System security execution environment covers the testing which is related to the other ecosystem which has been connected to the system that taken care in these things. And as Samir told, fuzzing, which is a very important test which we performed through very highly effective equipment which is we use for a fuzzing, that is a feeding of anomaly data to the device and see the robustness of the device, whether it has been revealing any kind of important or any confidential information while fuzzing. So that kind of test being performed. It has been very lengthy. For each protocol, we need to perform this test more than 60 hours, 72 hours, and 120 hours as respective of the protocol. So this is one of the fuzzing test which has been taking lengthy time. But yes, so as we discussed these 5, there are many more, as total 92 test cases for the routers and as 77 for Wi-Fi CP. So it is very exclusive test checklist which we need to perform for each of the product, and every product has to qualify for the certificate to comply with the 100% test cases. So NCCS has really made a great ITSR, which is make sure that every OEM should secure, they work on product secured by design. So because if their design is secure, then only they can achieve that one. So that will be a great achievement by the NCCS to set up this ITSR, and many of the products are passing these checklist and these test clauses. So now Samir has discussed about some of the graded system which is coming up, or which is proposed, right? It's not coming up. I say it's the proposed one, which is right now not finalized it. But as per the discussion being done with the NCCS and the respective OEMs, they have defined that there are few clauses which they identified for the basic level entry, graded system, which is a security assurance level 1. They are working. So all the devices should be passed with these test clauses. Then only they will get the security assurance level 1 certification. So these are still under discussions. These are not finalized, and these are not yet notified by the NCCS. However, these are been some which is the clauses which has been defined, and all the OEM should be ensured that they at least passed 80% of these test clauses to get the minimum security assurance level 1 certificate. Now, once this graded system comes, so we obviously have to see that how it will impact. So definitely it will impact both the side, either it's a OEM or it's a lab. So in OEM side, obviously it may reduce their immediate compliance pressure by enabling phased implementation, because they have the option to go for a different graded system. The costing of the testing fees, which is there, have a worry about that. So it will reduce because of the graded system. The number of clauses being decreased. Obviously the cost will happen, but it may lead to some unintended consequence as well. Now, reduce urgency of cybersecurity readiness. So because OEM would have option to go for only SAM1 certification, then they may delay the implementation of other security control which are needed to achieve the higher level of security in the device. So right now they can take the option of SAM1, but ultimately they are not achieving the all security control which are supposed to be there in the device. And going forward, as this been revised, if NCCS will revise this graded system on time to time basis, then they have to come back again on same implementation fees, because there will be a remediation fees that they need to work on. Compliance uncertainty is where if whether requirements are mandatory or deferred can lead to the confusion and inconsistent planning and investment decision, because if there is something which need to plan now, they have to defer it to the next year or next release. So their inconsistency will become a problem for their compliance. Increase future remediation cost, because if delayed delayed implementation of security requirements may result into the higher redesign and revalidation cost later. Competitive imbalance, OEMs that have already invested in compliance and secure development practices may disadvantage compared with the organizations relying on the temporary certification pathway. So many of the OEMs who are achieving 100% test compliance, they are at the upper hand, but who are only rely on the SAM1 basis, then they will be not in that competition which is they are looking for. And obviously the government of India is looking for that all the critical infrastructure where the devices should be implemented should be have a minimum SAM2 or SAM3 level of certification. So that's the insight which we are getting from NCCS. So whosoever is getting from SAM1, they have to upgrade their devices and they have to reach to the next higher level of security certifications. International inconsistent, yes, in several OEMs already comply with the more stringent global security framework at different substantial higher cost. Therefore, delayed adoption in India could create an uneven regulatory posture. So UCC or your common criteria, they have a very higher level of test cases, and they're paying higher cost for those testing. So now if they compare only for SAM1, that is not giving the consistency for as per the international level. So one graded system provides OEM with a temporary implementation flexibility, but the framework will be reviewed by NCCS in every 6 months, and any changes in the SAM1, SAM2 requirement or assessment criteria may again come for additional testing and compliance efforts. So that need to be sure that OEM taken a decision to that which level of certification they have to go for, and what is the product remediation if there is any failure or there is anything which cannot comply with the at least CM2 and CM3 level. So once this graded system comes, obviously it will impact the lab as well, because reducing testing demand, definitely it will reduce the sustainable cost for the lab as well. So in that terms, if we have extended validity period and lower immediate accessory requirement may significantly reduce the project inflow. That will obviously impact the lab in terms of their operation flow. Commercial and sustainability concerns. So laboratory have invested in specialized infrastructure, tools, skilled cybersecurity personnel over the last several years. So if this is going to be happen, then obviously it will impact the lab ecosystem instability. If accredited laboratories become commercial unstable, rebuilding national testing capacity would require a substantial time and investment. So that will also impact in that. And enforcement limitation, the weakened testing ecosystem may ultimately reduce the government ability to enforce cybersecurity compliance effectively. So right now, if there is such great system come, definitely the lab to survive as a lab, it will become difficult, and the demand will reduce. Then obviously it will be difficult to come or new lab should come into the market. In terms of the laboratory readiness for COMSEC testing, so all the which are the key indicators for laboratory readiness includes establish a testing infrastructure. So every laboratory have the invested in specialized cybersecurity testing environment, all the security validation platforms, the simulators, all the network tools which is required, all the security software which is required, like fuzzing, brute force, NCCS for vulnerability scans. So all aligned with the telecom security requirements. Skilled technical expertise, dedicated team with expertise in telecom protocols, network security, vulnerability assessment, penetration testing. So these are the capabilities and skills required on the workforce, and all are being highly qualified resources which has been hired by the laboratories. Operational experience, it should have that accumulated practical experience through multiple years of execution, market surveillance activities, and assessment of telecom and network design against defined security control. These testing of this one of the device on basis of HITSAR is not the easy, because either you have an application security engineer or your network security engineer. But in this case, we need the combination of the person who have the knowledge of the network as well as have a knowledge of the cybersecurity. So that combination is really very, very tough to find out. We need to groom the engineer to reach to the stage where they can do the network configuration and then do the cybersecurity assessment of the each devices as per the HITSAR requirement. Process in the quality system, the testing methodology, reporting structures, compliant workflows have been set up to support repeatable and consistent evaluations. That is one of the requirements as per the QMS and 17025. All the labs should be qualified in either from NABL or any other equivalent system. Scalability to increase demands. Yes, as existing laboratory capacity has been built in with the expectation of progressive expansion. Now we, as a GRM, we are working for four of the products, but we have the expansion we are for the cloud-based IP routers, cloud-based Wi-Fi CPs, firewall. We are working towards PABX, M2 and M3 switches. So we should have the capabilities to expand the test bed, expand the engineers, and then we all labs should have that readiness for all the COMSEC testing scheme. Yeah, thank you very much for the time, and thank you to Vincular team giving me this opportunity. Over to you, Kalpana.
Thank you, Mr. Sharma, for your valuable insights and for providing a comprehensive overview of the COMSEC graded certification scheme. Your perspective on the certification framework, testing requirement, and laboratory readiness have been extremely informative and beneficial for all our participants. Thank you to all our speakers for their presentations. Allow me to give you a quick overview of Vincular's COMSEC project experience and execution track record. At Vincular, we have successfully managed and supported more than 49 COMSEC projects across multiple telecom and network product categories. These includes over 30 Proton certification projects, more than 15 cloud acknowledgement letters, and over 9 provisional certificates. In addition, more than 9 applications are currently in the final stages of approval, and we expect the certification to be issued soon. Before we close, let us briefly share why organizations should choose Vincular as their compliance partner. At Vincular, we provide end-to-end support throughout the testing and certification journey, from understanding regulatory requirements and preparing application to coordinating testing and obtaining the final certification. Our experienced team works closely with regulatory authorities, accredited laboratories, and industry stakeholders to help customers navigating compliance requirements efficiently and avoid unnecessary delays. By managing timelines, coordinating activities, and handling the complete certification process, we simplify what can often be a complex and time-consuming journey. Our goal is to make compliance simple, efficient, and predictable, allowing our customers to focus on their core businesses with confidence. On behalf of the entire Vincular team, I would like to sincerely thank you, all our speakers and participants, for joining us today. We truly appreciate your time, attention, and active participation throughout the session. Thank you for your trust in Vincular and for being such an engaging audience. We hope you found today's webinar valuable and informative. Thank you once again for being with us. We look forward to connecting with you in future sessions. Have a wonderful day and stay safe. Thank you.